Hello students. For some reason my webcam just decided to stop working, so you won't see my smiling face welcoming you to Chapter 6. But I wanted to go through some problems with you again, just like I did for the prior chapter, that will work you through each of the learning objectives for Chapter 6. We're going to first go through problem 659A, as you see on the screen here, which is on page 369. That will cover actually our first 5 of 6 learning objectives. And then the next problem we're going to go through is P661A, which is on page 371, and that will take us through learning objective 6. So what I'd like for you to do is pause this screen here, or pause the video here, and read through all the requirements for this particular problem. Please note that this is quite a long problem. There are requirements 1 through 5 on this page, and then if you go to your next page, page 370, you will see requirements 6, requirements 7, and requirements 8. So pause the video and please take a look at those requirements right now. Okay, so you should have taken a look at all of the requirements. So let's start taking a look at our solution. So before we do that, let's just refresh our memory of what we're looking at for the first requirement. So given all the information here, for the first few requirements, we're looking at the overhead costs. We're going to look at some graphs and determine whether or not those graphs look reasonable. And then in requirement 5, we'll look at the high-low method. All right, let's move over here. So requirement 1, because you do see changes in your overhead, that would show that it does appear to be a mixed cost. If it were fixed, as it states here, it would remain constant each month, and if it were variable, it would remain constant on a per unit of activity basis, which we do not see in this particular problem. So that appears to be a mixed cost is what it looks like. Okay, now with requirement 2, they were asking you to graph the relationship between the hospital overhead costs and the nursing hours. Okay, so that has been done here with the nursing hours and your hospital overhead costs graphed, and we'll do some analysis of that in a moment, but that appears to be fairly in line there. I don't see any outliers. Then we were to do in requirement 3 relationship of hospital overhead costs to, this time, the number of patient days. So in this particular instance, we do see an outlier here, as you can tell. I believe this is in the month of September data point. So that was what requirement 4 was asking us to do, to take a look at these two graphs and make some analysis based on that. Because we don't see any outliers in this one, we can predict that that is a pretty good indicator of a driver, that the nursing hours is in fact driving the overhead cost. Now with the number of patient days, it does look a little questionable because of this outlier here. So what management would want to do is check this data before continuing to use any analysis. And we will be using other methods to analyze this in a little bit as well. Okay, so our last requirement for that first set of requirements on that first page there was, I believe, let's see, this was to use the high-low method. Okay, so using the high-low method, first we take the highest point for cost and the lowest point for cost. And you're taking the activity related to the high point and the low point. That does not necessarily mean that that would be the highest and lowest activity. Typically it would be. In this case it is. But you take that information and put that in here to calculate the difference. So our difference in cost and our difference in activity for the high-low method then is shown right here. Then we can take that information and we can come up with our variable cost. okay, by taking the change in the cost divided by the change in the volume from our high-low method will give us a variable cost per unit of our driver of $13.10. Then we can put that into our formula, okay, using the high point. So total cost equals our variable cost component plus our fixed cost component, or Y equals Vx plus F. Okay, so we know our total cost. Using the high point, 555,000 was our total cost. And we know our activity, right? 30,000. 30,000 of activity times the variable cost per unit of activity, which we calculated here as 1310, will give us our variable cost component plus fixed cost component. Okay, so we're going to solve for our fixed cost component here. 555,000 equals 393,000. Therefore, subtracting these out gives us F, or our fixed cost component, is 162,000. Therefore, we know our total fixed costs, and we can then plug that into any equation that we wish to use using that fixed cost component. Okay, so that's the last part of requirement 5. Let me just read that again to refresh your memory, since it's been a minute since we looked at that. So the last part of requirement 5 said to predict total overhead costs if 25,000 nursing hours are predicted for the month. Okay, so now we can just plug into our formula here the 25,000 of nursing hours multiplied by our variable cost per unit plus our fixed costs, and we can predict that our total cost would be 489,500. Okay, let's now look at the last 3 requirements. I'm going to switch over here and take a look at those together. So that would be on the next page, page 370. So for number 6, they're giving us a regression analysis chart here to use in order to do some predictions here. So if 25,000 nursing hours are predicted, what is the total predicted hospital overhead? Now this regression summary has already been prepared. Just need to know how to read it. So here is the 1426 is our X variable, and our intercept is $131,004.69. So we can use those in our formula. We also know that our nursing hours, our variable component of the driver, is 25,000 nursing hours. So we can use those in our formula now to predict our total costs. Okay, so there's the 1426 X, which now we put in as 25,000 because we were given that information, plus our fixed costs. So we have our variable cost component and our fixed cost component, which we got from our regression analysis, and now we know that our total costs are $487,504.69. All right, now let's look at requirement 7. And now they're going to run a regression analysis, but this time they're going to use number of patient days as the cost driver. So the number of patient days. So we're using the same information here again and putting that into our formula for our total costs. Okay? Now the final question is, which one of these would we have the most confidence in? Now that's another test of, do you know how to read the chart here? So one of the indicators here is our R-square. That gives us a number that tells us the higher the number, the more we can rely upon the data and the way that these work together here. So we have a much higher number from our output here related to nursing hours as our cost driver. So that is what we can trust to be a more reasonable. Let me pull up the solution here. We can have the most confidence in that cost equation. Our next problem, let me pull that up now. Our next problem that we're going to work on is problem 61, and that is on page 371. Okay, much quicker problem, much shorter problem. This is learning objective 6, and all we are going to do with this is prepare the income statement using a traditional format, what you would have learned in financial accounting, and now we're going to use the information to prepare a contribution margin format. So once again, pause the video and read through all of the information yourself. I highly encourage you to work through this on your own first, and then start the video up and look at the solution and see if you got it right. That would be a great way to study. Okay, so by now you should have read through the material. Now let's take a look at the solution. Okay, we're looking at 61. Okay, so here is our traditional income statement. We know we were told that they sell 88,000 units at $5 per piece. I believe these were ice cream cones. The cost of goods sold, we're told that they purchase the ice cream at $14 per tub, which provides them 28 servings. So therefore, the ice cream would cost 50 cents per serving. And then they also tell you that they purchase the ice cream cones themselves for 15 cents per serving per cone, for a total of 65 cents. Okay, so 8,800 of the number sold times 65 cents of the cost gives us our $5,720. Pretty nice gross profit there of $38,280. All of these expenses are operating leases. All of that was given to us to come with our total operating expenses and our operating income of $33,210. Okay, that should be a nice review. Now, contribution margin. Contribution margin, the only difference here is we're going to break out our variable versus our fixed cost, all of them. So the problem told you that let me read it here. During June, the shop incurred an additional $2,800 of other operating expenses. Okay, of those, 75% were fixed cost. So 25%, of course, were then variable, and 75% were fixed. So we can now break that portion out, and up here at the top, we're going to show only our variable expenses to come down to a contribution margin. Okay, contribution margin is our revenue minus our variable costs. Then below that line, we can show all of our fixed costs, including the 75% of those costs that were identified previously as being fixed, to come up with our total fixed expenses, and of course operating income will match what we have before, just a separate way of dividing that information out. Again, hopefully that information is helpful for you, and as always, please let me know if you have any questions. Thank you.